Alright, this is worksheet 9 of the Ionic Compounds packet, and this is really a review of something that you learned in the atomic structure packet, which is how to make a Lewis dot diagram. And as we move into the next part of this packet, where we learn about the bonds or the connections that hold metals and nonmetals together in an ionic compound, you are going to need to be able to represent these different compounds with Lewis dot diagrams. So, let's just kind of remember, right? Helium and neon up here are both noble gases, okay? Helium is in the first period of the periodic table, so it only has just an s orbital, and that s orbital can only hold 2 electrons, okay? So helium is a noble gas, meaning it's got a full outer shell. Noble gases always do, they're happy, right? But helium's a really funky exception, which is why I'm kind of highlighting it here, because it's only got, 2 electrons in its outermost shell, but that shell's full. Why? Well, because if this is the nucleus of helium, all it's got is just that 1s orbital in its outermost shell. And that s orbital, like all s orbitals, can only hold 2 electrons. Okay? Neon is more of a normal noble gas. So neon, if we look, is in the 8th family of the periodic table. Oops, I'm still drawing helium here. Okay, so we draw Ne, its symbol. And then because it's in the 8th column, it's going to have 8 electrons in its outermost shell. So 1, 2, 3, 4, 5, 6, 7, 8. Yes? All right. So noble gases don't form ions. Right? Why not? Well, you're going to answer this, and we'll talk about it in class, but I want you to think about how many valence electrons they have and what the goal of every atom is. Okay? Now, let's draw some Lewis dot diagrams for metals which do form ions. They form cations, positively charged. Okay? Beryllium is Be. So if we look, it is in the 2nd family of the periodic table. So it's going to start off with 1, 2 electrons. All right? In its outermost shell. Now, that doesn't make it happy. It wants to have 8. And because it starts off with 2, so remember, if it starts off with less than 4, it's going to give those away. It's going to say, you know what, this outer shell's not full. It's so far away from being full, having 8, that it's just not energetically possible for me to steal enough electrons from other atoms to fill this shell, so I'm just going to scrap this shell. So it's going to give them away. So that shell is now going to be empty. And when you get rid of 2 negatives, it gives you a charge of positive 2. Right? If you get rid of negatives, it makes you positive. Okay, so you're going to go on and do aluminum, magnesium, and sodium in a similar way, and then I want you to generalize. Right? I want you to look at this, and this, and this, and this, these 4 ion diagrams, and tell me, what do they have in common? Okay? Then we'll look at, down here, the Lewis dot diagrams for these nonmetals, which are going to form negatively charged ions, or anions. Okay, if we look at oxygen, it's in the 6th family of the periodic table. So 1, 2, 3, 4, 5, 6 electrons. It's not happy. It wants to have 8, and it's starting off with 6 electrons already in that shell. It's very close to 8. Remember, if you have 4 or more electrons, you're going to try to steal electrons from other atoms until you can fill your shell. So indeed, that's what it's going to do. 1, 2, 3, 4, 5, 6, 7, 8. It's going to steal 2 more. Well, if you gain 2 extra electrons, they're negatively charged, right? That gives you a negative 2 charge. Okay, so you're going to go ahead for chlorine and for phosphorus, do the same thing, and then compare this, this, and this, these 3 ion diagrams of anions, and just generalize. What do they all have in common? All right, and then we will move on from here when you get to class.